Hey guys, all right. This is Unit 4. We are today studying composite functions or composition of functions. So our first 5 questions are review questions, and hopefully you guys remember how to do this from Algebra 1. Review. Given the function f of x equals square root of x squared plus 1 and another function h of x equals x minus 2 to the third power minus x. Question 1, find f of 2. Remember, I'm giving you two functions, right? An f function and an h function. So these are the name. Anytime you see an f of x, it's the name of that function. And then h of x is like another name. So think of it as like two different persons, right? So one is named like F for Frank, or the other one is H for, what would H be? Hank, Frank and Hank. So part 1 says find f of 2. Because I'm using f of 2, meaning that you have to use the f function here. The original function was f of x, but now we are looking for f of 2. That means every time that we see an x variable in the f function, f equation, we plug in 2. So f of 2, we plug in 2 for one x location. Let me just highlight your x location here, right there. And that means 2 squared plus 1. All of that is under the radical. Then from there on, we just do the basic math. So f of 2 is 4 plus 1. So f of 2 would give us a square root of 5, and leave it as an exact answer. Now, question 2 says h of 5. Now, do we go and use f of x, or do we go use h of x on this question? Right, we have to go use h of x. And now in the h of x, we have two x locations. That means we need to substitute 5 for both locations. So h of 5 is quantity blank minus 2 to the third minus blank. So both of those locations will get a 5. That's really what it is doing. Then from there, once you're done substituting the 5s in for the h, then we do basic math and simplify. This is going to be 5 minus 2, which is 3 to the third. Take away 5. So h of 5 is going to be 3 to the third is 27. Take away 5. h of 5 is going to come out to be 22. So now, why don't you take a minute and do question 3. And remember, this is a review, so I want you to try it as much as you can. So go ahead and take a minute and do example 3. I'm going to hit pause, so I'm not going to so the time of the recording doesn't take long. So hopefully by now you have at least filled in negative 11 for the two x locations, right? Both are negative 11. So from here, we will now work the basic math. h of negative 11 equals negative 13 to the third power. A negative and a negative is now an addition of 11. So we will try to find negative 13 to the third power. That's kind of like saying negative 13 times negative 13 times negative 13. That will get us a very large value of a negative 2,197 plus 11. So from there, we would just combine like terms with negative 2197 plus 11. That will give us a negative 2186. So how is that any different from the next two? They're not really different. You just have to substitute in this right here every time you see an x variable of the original. So for this one, I'm going to draw a line. For this one, every time I see an x in the original, I will now leave a blank space. So I'm going to draw a radical, and what I'm going to do is blank space, and then square, and plus 1. All of that is still under the radical. What do we do with the blank space? Well, we fill in 1 plus x, just like that. And once you fill that in, just simplify here. I'm going to write it in the bottom. I'm going to write it out twice so we can distribute it properly. From distribution, we're going to get 1 times 1 is going to be 1. 1 times x is x. X times 1 is x. X times x is x squared. And then I still have this 1 that we need to bring down. If we simplify and put it in standard form, I'm going to put the x squared in the front. And we have 2 x's. And then we're going to add the 2. Now, if you can factor, try to factor it out. So usually when I try to factor it out, I make my x in the, and then 2 on the top, 2 on the bottom. There aren't any 2 numbers to multiply give me 2 and add give me 2. So therefore this is not factorable. If it's not factorable, you can just box it up. Or if you have a highlighter ready, you can just highlight the answer. And that's as far as you can go for that question. So this really is now technically f of 1 plus x is the square root of x squared plus 2x plus 2 if you want to rewrite that. Okay. Now number 5 says find h of z. Well, z is a variable and that's okay. So all this is doing is taking the original equation h of x and substituting with z every time we see an x. And that's exactly the same thing. So I see the x here. That means I'm going to plug in z on those 2 locations. So those both get z's. And because we don't need to multiply these out or distribute these out because it's not going to help us simplify. So we can just leave this the way it is. If you want to sit here and distribute the z minus 2, write it out 3 times, feel free and go for that. But technically, you are not required to. So that's a review from Algebra 1. Hopefully, that gave you an idea of where we are going, okay? Our next definition is composite function. That's our definition, and let me just pull that up. Oops. Okay, so let me find that. Sorry, we have lots of notes so far. Okay. Here we go. So go ahead and copy this down. I'm just going to hit pause on my end so it doesn't take too long. Okay. So composite function, it's an operation. Okay, I want you to understand that word. Operation means it's the same thing as addition, subtraction, dividing, multiplying. Those are all operations. It's an operation. This is red. Okay, this is, whoops, this is red. G of f. Okay, G of f. Or it's sometimes read G is composed with f. So when you see this little bubble symbol in between 2 variables, it's not a multiplication, it's not a degree symbol, it is read G is composed with f or G of f. Okay, composition or a composition or a composite function, meaning that we take 2 functions, let's say f and g, and produce a new function called h, such that this new function called h of x equals g of f, which means the same thing as if we were to compose g with f of x. Okay, so let's go and try a couple of these. Now the next 4 examples, we are going to just purely composite with the number, okay? And then later we'll do the compositions of 2 of them and then still keep the x in there. But right now it's going to take 1 step at a time. Now if it's going too fast, you can always pause it. That's the nice thing about video notes. So example 6, 7, 8, and 9. Okay, the instructions are at the above. Given f of x equals 2x squared plus 3, and g of x is 4x to the third plus 1. Find f of g of 1. That's how this one is read. Okay, again, this is read f of g of 1. That has the same meaning as f of g of 1. Well, you know how to do that already. We know how to find g of 1. So the first thing we will do is find g of 1. Well, that's the same thing as the review questions that we just got done. We go and look for the g function and we plug in 1 for every time we see an x. Well, we have 4, I see an x to the third plus 1. So g of 1 equals, now let's plug in, every time I see an x, I'm going to plug in 1. Well, 1 to the third is 1, 4 times 1 is 1. So, I'm sorry, 4 times 1 is not 1. 4 times 1 is 4. 4 plus 1 is going to give us 5. So g, I want you to be very knowledgeable about this. G of 1 is 5. So what do we do with this right here on the top? We go and now we say, okay, f of g of 1, well, g of 1 is now really 5. G of 1 is 5. So now we find the last part. So there's like 2 parts to one of these questions. You find the inner component first, and then you go and do the outer component, okay? So now we do f of 5. This is the second stage. Well, then every time I see an x in the f function, I'm just going to go and put 5 in. Okay, there you go. Then just do basic math. So now this will give us 2, 5 squared is 25 plus 3. That's going to be 50 plus 3 is 53. So this function, f of g of 1, is the same as f of g of 1. Both of these notations are exactly the same. Comes out to be 53. So we take this last answer, because that's the second stage, and that will give us the final answer of the entire question. So now let's draw a line, since as you can see, I invaded the spot here. Now number 7 is g of f of 1. Okay, very similar in notation as you can see, but now this is g of f of 1. So what this is meaning that we are going to do f of 1 first. Okay, so by definition, these two have the same meaning. So first stage, we're going to do f of 1. Well, do you think 7 and 6, question 7 and question 6, do you think they will come up with the same answer? So do you think we will get the same answer from question 7 as to question 6? Okay, so hold on to your answer. We will test it out right now. First, we're going to do f of 1. That means every time we see an x variable, we will substitute it with 1. Okay, in the f function, for this f function, we only have one location of x. Therefore, I only have to do it once. So f of 1 is 1 squared is 1, 1 times 2 is 2, plus 3 is 5. So f of 1 is 5. The second stage is now, remember, we take this out and we substitute what? We take that out and we substitute with this guy, right? Because that's what f of 1 is. So that's g of 5. Now we look at g function, and wherever we see an x originally, we put in 5. So now we get 5 here. So go ahead and do your basic math. This is going to be 4 times 5 to the third. Go ahead and give yourself a second to think. That's 5 times 5 times 5. That should give you what? Good. Okay. Now 125 times 4. Well, you know 100 times 4, that's 400. And then 25 times 4 is another 100. So technically, you should end up with 500 total. 500 plus 1 is going to be 501. So g of f of 1 is the same thing as writing it this way. Okay, g of f of 1 comes up with 501. So that answer, it's the final answer that we needed. Okay, now we have two more examples on this same concept here. Let me draw a line. I shouldn't be invading the space of question 8 or 9. I'm going to try my best to be a little bit more organized. Let's do, okay, yeah, I'm going to do 9 over here, okay? There you go. Okay, 8 says f of 1. So f of 1, meaning that f of 1. Well, that means we're using the function f twice. So same thing, the first stage is always the inner component first. So look at your f function. You only have one location of x. So f of 1 equals 2 times one location of x, and that's when we plug in 1, just like that. So this one by now, f of 1 should give us 5. Okay. The second stage is do it again with the outer component. Okay, it's this outer component. I'm going to highlight that. That's guy right there. So the outer component is f of blank. That means f of 1, but f of 1 is 5, so we plug in 5. So we're going to get 2 times 5 squared plus 3, which will give us 2 times 25 plus 3, which will give us 53. So this example, number 8, f of 1 equals, same notation. If I were to write it this way, it equals to 53. Now you can see, I'm going to highlight the answer. You can see that example 8 and example 6 have the same answer, but it just by a pure coincidence. Okay, it's not always like that. It just happens in this case. It's not always the case that f of g of 1 is the same as f of 1. Okay, last example for this type of question. Now we're going to try to do g of 1. So let me just get a different color pen to kind of separate ourselves here. How about black? So g of 1, by definition, we can write it this way. When I write it using parentheses, it's a little bit easier for me to decide what to do next. So your first step will do g of 1, okay? And the g function is 4x to the third, so now I'm going to write 4x to the third. That means I'm going to fill in something to the third, and then we add 1 at the end. So that spot will get 1 because that is a 1. So this number should always be the same. So that was going to give us 5. Then the second step, okay, we're going to do g of 5 because now we're trying to do the outer component. And because it's the same function, I know what to do. I'm going to leave that blank space there. And I'm going to fill 5 right there. And I feel like we did this already. Okay, g of 5, that was the same thing as number 7, g of f of 1. So I will get the same as 501. Now again, these two are just pure coincidence that they are the same answer. It's not like this all the time. It could be, but it doesn't have to be. Okay, and I'm going to box up 501 and box that up. So again, if you need to re-listen to this, then just hit pause. That's the best thing about recording notes. Now I'm going to pinch it in because it's frozen. Okay, I'm going to move it out here for a little bit. Okay, what the next page, if you are looking ahead, why don't you give it your best shot and try these on your own. And during our next video notes, I will show us the answer to see if you were able to do it all by yourself. If you can do it all by yourself, great. That means you understood it really well. If you can't, try your best to do the ones that you know how to do. And the next video, you can watch it to see where you went wrong and where you need help with. Okay, until then, adios.